Hi all. Today we are going to demonstrate how to build a model for predicting the accuracy and probability of default credit card payments using multilinear regression. To complete this process we need to have some prerequisites. They are, Scala SDK, default of credit card clients.csv file. Regression analysis is a set of statistical processes for estimating the relationships among variables. It includes many techniques for modeling and analyzing several variables, when the focus is on the relationship between a dependent variable and one or more independent variables, or predictors. Regression analysis helps one understand how the typical value of the dependent variable, or criterion variable, changes when any one of the independent variables is varied, while the other independent variables are held fixed. Predicts continuous class labels. Create an application to build multilinear regression model. Click on File New Scala Project. Enter project name and click on Next. Click on Libraries, add external jars. Navigate to Spark installation folder and open jar folder, then select all the jar files and click on Open Finish. Open Spark_multiple linear regression and add package to src folder by selecting New Package and give some name and click on Finish. Then add Scala object to package by selecting New Scala object and give some name and click on Finish. Write a Scala program to build multilinear regression model. Define main function. Use logger function to eliminate unnecessary info logs and to show only error logs. Create Spark session, which provides a single point of entry to interact with underlying Spark functionality and allows programming Spark with data frame and dataset APIs. Read the CSV file into RDD by using Spark context and text file functions. Use first and filter functions to remove header line from your dataset. Now split the data into label and feature, where label is just the value you're trying to predict, and feature is the data you are going to make a prediction with. So in this demo the labels are the first column of our data, and features are the second column. You can have more than one feature, which is why a vector is required. Create a sequence by using sc function to assign column names for our data. Convert the RDDs into data frames using toDef function and assign our column name sequence. Now our data have been divided into label and feature. Use random split to split your data into training data and testing data. Now create a model using linear regression and assign some parameters to set the regularization, maximum number of iterations, elastic mixing and convergence tolerance of iterations. Now train the model using our training data. Print the coefficients and intercepts by using coefficients and intercepts methods. Summarize the model over the training set and print out some metrics by using summary method. Print number of iterations using total iterations method. Print objective history using objective history method. Use residuals method and find out the difference between actual data minus predicted data details. Print root mean squared error by using root mean squared error method, where it measures how much error there is between two datasets comparing a predicted value and an observed or known value. The smaller an RMSE value, the closer predicted and observed values are. Print R2 R squared value using R2 method, where it shows how close the data are to the fitted in regression line. This score will always be between 0 and 100%, or 0 to 1 in this case. That means that, in general, the higher the R squared, the better the model fits your data. Generate predictions using transform function by fitting your data into your linear regression model. Then your predictions will be added under prediction column to our testDF data frame. Select the columns you want to display in output using select function. Print out the predicted and actual values for each record using println function. Run the code to see the output in the console window. This is how you can predict the accuracy and probability of default credit card payments using multilinear regression model. That's all for this video. For any queries please reach us at vj.ready@sangam.ai.